Good morning for you, everyone. So I'm glad to have got this invitation to give a speech on biostimulants and this interesting conference on potato. So actually, the lady who presented me say that I'm responsible of this company, LANDLAB, which is located in Italy, and then we are focusing our activity on research and development for special fertilizers, special biostimulants, and plant protection products. So what does it mean for us, biostimulants? So let's go ahead and see if biostimulants are really new products. So since almost 70 years, the word biostimulants is appearing in the market by several scientists with different definitions. As you can see in the screen, the first time the word biostimulants appeared in 1951 in Russia, by the way. So from this point on, many scientists, many papers have studied the effect of products which are somehow inducing to the plant's responses, which are not related directly to the nutrition, even not related to the water. So in the last years, biostimulants have got a dramatic boost in the science. In this chart, we may see that almost until year 2000, there were little studies on the biostimulant subject. This study has been committed by the European Commission to a professor in Belgium. So it's quite a relevant study, and it shows that starting from 2003 up, the number of research focusing the attention into biostimulants was dramatically growing. So in few weeks, actually next week in USA, we'll start the 5th Worldwide Biostimulant Conference, which is collecting people from all the continents with more than 1,500 participants. So saying that really recently, biostimulants got a lot of attention for their potential into agriculture. But until 20 years ago, this word was completely unknown by scientists, by technicians, and of course by farmers as well. Where are biostimulants located in the legislation? Because we all know that a product to be sold need to have a position somewhere in a law. So actually today biostimulants are connected with mineral and organic fertilizers and with the soil improvers and growing media. So they are in a category which is completely different from plant protection products. So because they actually do not have any specific law. And for instance, Europe, only next year we finally open a chapter in the new fertilizers law in which biostimulants are allocated precisely. So you see that even Europe, which sometimes is advanced, it does not have up to now an European legislation on where biostimulants are located in the frame of the regulations. But are there biostimulants precisely there? Are they really fertilizers? What are they doing? So actually biostimulants are what we call in the green zone, in the gray zone. So they are located between the support to the plants and the plant protection product. So biostimulants are not bringing any fertilizer. I will come back to this concept later. They are not bringing any NPK, any micronutrients. They are not directly fighting the pathogens and neither the insects. They are somehow working on the plant's physiology directly or mediated by a soil or by a bacteria. So they will be in the law as a fertilizers, but actually they can act as inducer of resistance. So that's why we say they are in the gray zone between biostimulation and plant protection. In the future, we'll have some troubles for this reason. But so what are actually biostimulants? So they are products which function is to stimulate plant nutrition processes independently of the product's nutrients content. So actually, they are not bringing any nutrients. They are activating plant responses or soil responses or microbial responses or fungi responses in the rhizosphere. Therefore, acting as a booster of the nutrient use efficiency, the tolerance to abiotic stresses, which are defined, I will define very soon. They are improving the quality traits of the plants or the crops, and they are increasing the availability of the nutrients in the soil and rhizosphere. So all these four traits, traits are characterizing the role, the activity of the biostimulant. Are they products different from the plant protection? I would say yes, because different from the plant protection, they are not substitution technologies. So biostimulants are not substituting any existing product. They are an incremental technology. So they are increasing the expression of the genetic potential of the crop. So this is the key of the biostimulant. Is not to nourish the plant, nor the soil, not to fight insects or pathogens, but to positively affect the plant, the physiology of the plant, and therefore increasing the expression of the genetic potential of each crop in the area, of course, in the soil, in the climatic condition it is growing. So our final target with future technology would be on further enhance the expression of the genetically determined potential yield, which is today not fully expressed clearly. And some years very low expressed and some years more, depending on the external condition. So this is for us a new technology which is incrementing the plant's performances due to via different tracks, different paths. So, which are the challenges today of the agriculture? Agriculture is facing many troubles, and more also because for the reason precisely in the last days we have been hearing and in the media and wherever, so related to the climate change conditions. So plants and crops therefore are facing several critical conditions, which are we can split them in two main categories, which are the biotic stress, insects, pathogens, bacteria, virus. And on the left, we have the abiotic stress, which is heat, cold, nutrients, micronutrient deficiency, drought, excess of light, salinity, and flooding. So actually, abiotic losses are more relevant than biotic ones. But up to now, we didn't have any tool to counteract, to fight the decrease of the plant expression via the abiotic losses. So today we can do that, and in the future we can do even more. So that's how we define biostimulants, working on the left side of the screen you have. So abiotic stress is the main focus. Thinking that plants, crops are never considered to be in the comfort conditions. So which are the major challenges today? I would go from two cases. One is what we call the nutrient use efficiency, and the other is the water use efficiency. Water is getting scarce or erratic, sometimes too much, sometimes nothing. And nutrients have been overused in the last decades, from the 60s year up to now. Although now the usage of fertilizer is decreasing, still we are using far more nutrients that the plants can uptake. But there would be another chapter. So the goal for us in the future would be to produce more or the same with less input. And you can see the case of phosphate, which is today the phosphate nutrition is based on rock phosphate, but in the future, due to the fact that mines of phosphates are getting early and quickly empty, we have to deal with a different usage of phosphate, using less and by reusing phosphate from other sources. So this is a typical case on what will happen from 2030 ahead. So produce more with less or produce the same with less. This is the key of the future agriculture. So what are biostimulants doing? So they are boosting the nutrient efficiency, they are increasing the abiotic stress tolerance, they are improving the crop quality. So at the end, they are improving the plant's growth and yield. Let's go more in detail and see here, based on several studies from this researcher, Bosniak, published just 1 year ago, that many, as you can see here, that many, some traits of the crops are impacted by the stimulant, by biostimulant. So mainly yield, quality, should grow, nutrients uptake, and abiotic and biotic stress, less, for example, seed germination, root growth, and the blooming and fruit set. And within each column, you can see the products that are impacting the specific trait, the specific parameter, the yield, quality, or nutrients uptake, and so on. In some cases, you see that majority are induced by seaweed extracts, then by amino acids, humic and fulvic, live microbes, and little by other products. But we will see soon why that's happening. So what is the landscape we have today of biostimulants? We have a quite broad landscape of emerging products. So the main one are the acids, humic, fulvic, the amino acids, so proteins, peptides, other organic acids, fatty acids. And then we have the minor products today, like extracts, seaweed, that's a major product, but many other which are really minor, botanicals, polyphenols, and so on. On the right, we have microbials, which is a subject emerging now in the scenario, in the landscape of biostimulant, but still very young, still in a very early phase, still not fully reliable, not constant, not consistent in the performance induced when applied to the plants, when applied to the crops. So let's see how is today the worldwide market. Just 5 years ago, the worldwide market was about 1.7 billion US dollar, growing up to 3.2 in just 5 years, almost double, and is forecast to go up to 5.86 billion euros in the coming 5 years. So in 10 years, this market is becoming, let's say, 4 times bigger. So which is a very significant growth, a very significant increase. And the forecast for the next 10 years for this specific segment of the agricultural products is of a growth of 10 to 12% per year in the coming 10 years. So meaning that this market will really grow up dramatically and have a big impact on the farmer daily activity, on the farmer practice, which is not, it was not the case until just 5 or even 10 years ago. You see that the major area impacted by biostimulant use is Europe, followed by North America, so United States and Canada, and then of course Asia Pacific and Latin America. And other rest of the world is a minority. So these continents, the continents are really growing substantially in the use of the products everywhere. If we go inside this panorama, this scenario, we see that the main product use, accounting for about 90% of the market, are humic and fulvic, amino acids, proteins, hydrolysates, and seaweed extracts, where seaweed extracts are almost 50% of the actual use of biostimulants. So the other products are playing a role just for 10%. But this landscape will change very soon, because the market is very sparkling, growing, and several researchers and companies are looking into the products and working on innovation for that. Where are biostimulants working in the plants? This is what we call the mode of action. What does it mean, mode of action? At the end of the story, a farmer, of course, want to see a better plant, better yield, healthier, nicer fruits, or whatever, roots, a good marketable yield, and so on. But we, to develop biostimulants, have to go back and back to see where they are acting. So they can act at the DNA level, so the expression of the genes. They can act, DNA can have an impact on RNA, so the transfer of the message to the cell. The RNA is transferring the message and produce more proteins, which in plants are enzymes, and the enzymes are at the end leading to a production of specific metabolites. So these 4 steps say that we can go back and see where the biostimulants are impacting the plants. There are 4 science working on this area. One, at the end, what we are looking is the phenomic, so the phenotyping, the plants, the phenomena, what is appearing to us, which is a plant with the roots. But to get this one and to understand what's happening here, we go back until the DNA expression. So we have several scientific questions. What can happen in the DNA? What is the DNA doing? What is the RNA writing? And what at the end is happening in the plants, leading to the change of the phenotype of the plant. So this is what we call the mode of action, and this is necessary to have a right use of the products we apply. So nothing to do with the nitrogen. I apply more nitrogen, I have a better growth, or more potassium, I have more sugar, or more phosphorus, I have a better root expression, and so on. We are here in another part of the plant physiology. So let's go to the key categories now, which are the 3 I defined before: humic, proteins, and seaweed, and see one by one shortly how they are, what they do, where are the problems, where are the troubles, where are the mites on these products. So humic and fulvic substances are used since more than a century. There is a large literature on that. They are widespread in nature, and they have 2 main effects. They are working directly in the soil structure and fertility, but also having an impact on the nutrients availability and the root architecture. So humic and mainly humic acids, fulvic are acting differently, but humic acid mainly, they are working on this part of the rhizosphere, so impacting both soil, microbial community, and roots. In fact, if we look to the claims of the industry, there is a very large claim that you can find in the label, in the leaflets of the industries delivering to you, to the farmers, humic and fulvic acids. It looks like they can do almost everything, which is actually not true. But in fact, humic acids can do a lot. Not easy to be used for many reasons: the moment, the quantity, the type, but with a great potential. So let's look what are the strengths of the humics and the fulvic, and which are the weaknesses of the humic and the fulvic. So I'll say they are active in the soil-roots interface. They are conditioning the soil. They are promoting nutrient chelation, and they are stimulating the hair cell division. But what is weak in the product is that there's still a very broad definition. Not easy because of the structure and the molecular weights. They can have a very large variation, often from batch to batch, and each product claims a very broad activity. which makes the users a bit confused, because at the end of the story, somebody says, okay, I can do with the humic acid everything, which is not true. Amino acids and protein hydrolysates. Those are mainly leftover wastes, byproducts of agro-food industry or leather industry, fish, and so on. So they are not produced specifically for agriculture, but they are derived from other value chains. They can be produced by chemical or enzymatic hydrolysis. They might have a different hydrolysis degrees. They can be applied to roots and leaves, and they are used at very low quantity, therefore delivering to the plants a very negligible quantity of nutrients. But in the main claims, they are related to the stress tolerance and to enhance the biomass production. But let's see the key parameters of these products, so the proteins or amino acids. So nitrogen is low, depending if they are plant or animal derived. And another parameter which is often overestimated is the percentage of free amino acids. This is, to us, a myth. There are many messages saying that the more free amino acids there are, the more biostimulant activity there is, which is actually not true. It looks more and more that the small peptides are active and not the free amino acid. But still, some national legislation say the more free amino acid, the higher the value of the products. And there are no scientifically evidences that this is happening, really happening. The last product, which is actually the first biostimulant today in the market, are the seaweed, which are plants derived from the ocean mainly, the cold oceans. And Canada is one of the largest producers in the world. And they work in many ways. They are mainly working, inducing resistance to abiotic stress, if applied to the plants, directly to the leaves, but also if applied to the soil. Their action can be very wide, and depending on the type, depending on the mode of application, depending on the mode of extraction. They are extracted by several species, so mainly the 5 you see over there, Ascophyllum, Laminaria, Undaria, Ulva, and so on. They might be extracted by different methodologies and vary from region to region and season to season. So what makes this critical? Because the weaknesses of this biostimulant is the inconsistency. So maybe a producer can guarantee almost the same quality, meaning the same components, but you might understand easily that as they are growing in the ocean, and they can be harvested in different seasons, and they can be extracted in different ways, that the variation inside the liquid we have in the bottle can be dramatic. And therefore, also the effects can vary dramatically. So how to guarantee the consistency over time, this is the main constraint for the seaweed producers, and of course for the end users as well. But still, seaweed might have a relevant impact on the cropping systems. So just an example here, quite complicated, but I will not go through all these parts, to see that on the phosphorus use efficiency, which is one of the most critical nutrients for the plants, for the many reasons you know. Phosphorus is often blocked in pea pools, which are making it not available for the plants due to high or low pH. So phosphorus use efficiency can be dramatically changed by the use of the biostimulants. Either because making the phosphorus more available in the soil via the microflora, or because increasing the P uptake by giving signaling to the root hairs, which are exudating protons and therefore uptaking more phosphorus, or because the phosphorus movement, so the transport from the roots to the leaves is made easier because more P transporters are produced by the DNA signaling. So there are 3 different levels in which biostimulants can act only for the phosphorus. So solubilization, acquisition, translocation. So, and products can have impact on one or the other of these paths, which are crucial for the what we call PUE, phosphorus use efficiency. Water. Plants are transpiring, and because are transpiring, they need constantly to uptake water. In this experiment performed in our greenhouse with loading cells, we measure every half an hour, even often, the water transpiration of these maize plants. And you can see in this chart that this orange line, which is the transpiration, so the water loss of the plants based on night, day, is different from the others, which are the blue, the yellow, and the green, only because this plant has been treated with a different product, with a different biostimulants, leading to low transpiration. So biostimulant can induce lower transpiration or more transpiration. In some cases, low is better. In some other cases, more is better. So this has something that has to be decided according to the cropping system we have, with or without irrigation, with weather forecast, and so on. But the biostimulants can impact what we call the stomatal conductance. So changing the quantity of water that can pass through the stomata, go to the air, therefore needs to be uptaken by, from the roots in the soil. So biostimulants are impacting the transpiration. And there are many papers and researches as we do showing that. Now I will shortly go through these slides where I show how we work, for example, in the study of the biostimulants. We work by using a special platform, which is what you see over here, which is a 3D laser scan. And we can follow the plants continuously, automatically, day and night, Saturday and Sunday. So without any person looking to the plants. What we got? We got precise information on the plant's behavior. So here you see the so-called NDVI, which is the differentiation vegetation index, which is a signal of the plant's health, which is measured automatically with this instrument, and is saying that, for example, these plants are better than these plants. And we can measure that continuously. In this, and we got the shape of the plants, the growth, the height, the digital biomass, the leaf area, and many other physiological parameters. In this experiment here, you can see that where we induced a reduction of water, the full control was obviously performed better than the other. In this part of the chart, the full control has a stable and growing digital biomass, but the other products, because of the drought, and you see the drop on the leaf area, but some of the products, here we tested 10 products together, some of the products have a much better effect than others. So the green line is significantly below, for example, these lines, telling that this product has a no effect on the plant's growth, or this product has. So at the end of the cycle, there are biostimulants which are pushing the plants to grow as good as the full water, although they got far less irrigation. And you see the red lines here are the 2 periods of drought, which have a collapse of the growth of the plant. So again, by looking to the plants closely, continuously, twice or more per day, we can detect how the products are working. Another impact that the biostimulant can have are the reactive oxygen species, which are indication of stress. And plants, biostimulants can take out the reactive oxygen species and therefore have induced more stability in the plants. So like the antioxidants we also often use in our diet. Conclusion. The determination of the action is requires quite deep studies. Biostimulants can act in many different ways. There are approaches getting very deep into the plant's physiology to understand how they are working. And at the end, when data are required and a product is produced, we can know how to use, when to use, how much, in which crop, in which moment, and so on. So it's not that simple as a fertilization of urea or potassium sulfate is. It's much more professional, the use of this product. Let's go to, so here again, they can work at whole plant level, at the cellular level, and at molecular level. So they can really have an impact on different plants level. Let's go to the crops. Let's go to the experiments. I will show just a few of them. Actually, we at LANDLAB are running more than 200 experiments on biostimulants per year. So in the last 5 years, we have run more than 1,000 experiments from greenhouse to open field, all across Europe, from the South Italy to the north of Europe. So to climates close to the climate you have. So this is on potato because I understood that this is a potato conference. So this is a trial performed in our research station last year. What we did is quite simple at the end. We use two types of biostimulants, which are humic acids. Humic acid I call A and B. We reduce the phosphorus application by 25 to 30%, and we assess at the end the yield. We use also a type of phosphate, which is not soluble, which is the rock phosphate. Instead, on the full phosphorus, we use TSP, which is triple superphosphate, which is much more soluble than the rock phosphate. So not only we reduce the phosphorus, but also we reduce the solubility of the phosphorus. Good, and by using the biostimulant, we could increase by 11 or 18, let's say, up to almost 20% the yield compared to the untreated plants. And getting closer to the full phosphorus with high soluble P. Meaning that biostimulant, special humic acid in this case, had a significant power in making the P more soluble, in making the potato root system more widespread, and therefore uptake more nutrients. These trials were performed by a grower of potato in the north, a large grower with several, maybe 40, 50 hectares of potato every year. So not experimental station, but real conditions. In this case, we use a bacteria consortium plus seaweed. And also in this case, and there was no phosphorus reduction, so it was a standard cropping system, cultivation method. And this is the control. And those two are the treatments with bacteria, phosphorus solubilizer, or bacteria phosphorus solubilizer with seaweed. And you see that we grew from 57 tons up to almost 62 tons, with a growth of 8.5% compared to the untreated control. So in this case, a completely different product, not humic, but bacteria and seaweed, lead to increase in the potato yield. This is a strawberry experiment in Serbia, so in East Europe. I took this experiment because a part of the fact that the use of a different biostimulant, which is a plant extract, was leading to an increase of strawberry production. This is the control, and this is the special product developed by us, by the way, which had a significant increase in strawberry production. But what was interesting and unexpected, that at the end of the trial, you see in the chart on the right hand, the treated plots had a significant higher quantity of available P in the soil. So not only the strawberry could uptake more P, but the soil, but some P, which was in insoluble pools, was made available from the biostimulant and the plant's roots for eventually the next crop. with a significant quantity of increase in milligram of P per 100 gram of soil. So this was an unexpected output we got from this experiment. That's why I'm showing. And the next one is on sugar beet, also in the Eastern Europe, Croatia, also very large producer of sugar beet. This product has been foliar applied, so a different extract, a different activity. And in this case, also we got very significant growth in the yield from 50 to 86 tons, and a significant growth also in the sugar of the beet from 60.8 to 19. And this was the second year in a row, and this year is the third year in a row that we got similar results. So you see soil applied, foliar applied. I show you up to now 4 or 5 different biostimulants with different mode of actions and different actions in the plants. And at the end, I show you this chart, which is the summary of a very large number of essays we, LANDLAB, with an industrial partner, performed all across Europe, from Sicily, so actually close to North Africa, to Scandinavia, so Finland, on many different crops, so 36 trials in open field, and we got, on 36, we got 33 positive and just 3 negative below the normal farmer practice. And in 66–70% of the experiment, we got a very significant statistically difference compared to the untreated, saying what? That not always biostimulants are working, that get 70–75% of positive results is already a very consistent data, that in some cases the application is not leading to any significant growth change, or even to little decrease in the plant's performances. Can be for different reasons, of course, but it is happening. So I'm very glad I can show, I got the last data a few days ago. I can show this chart because it's a wide, it's based on a wide and different number of trials on many crops, from melons, apricots, eggplants, peppers, tomato, strawberry, and soybean, maize, and potato. So every type of crop in a different region, a climatic region of Europe, with different products, of course, in different application methodologies. So I'm at the end to say what? That biostimulants, abiotic stress can have potential which is often above the single abiotic stress. For example, I just comment this combination we know very well. If I combine the heat with a drought, I might have far more damages than the heat per se on the drought per se. If we combine UV with, for example, with drought or with heat, also in this case, the damages are dramatically above the damages generated by UV per se. So often there are stress which we don't see, excess of light, excess of UV, excess of nutrients, and these stress are combined with other critical conditions. So I try to summarize in one chart what are the target of the biostimulants. To make a story not easy, because it is not easy. So it's not like applying an irrigation. I know I give him water, I guess in the right moment, and I know how the plants are responding, or I'm giving nitrogen in a potato or potassium when it's needed. But in this case, we can have different targets. So the first one is the nutrient efficiency. How to increase the nutrient efficiency of a crop. The suggestion is to treat before and the soil eventually, and at the beginning of the crop cycle. Not relevant, for example, if I would like to increase the phosphorus use efficiency, is not relevant to apply biostimulants too late in the season. If the critical event are the abiotic stress, strong, like drought and heat waves, we have to work in two ways, before and after the stress is appearing, never during. Because if we apply something to a plant which is already stressed, during the stress, we are adding critical factors to an already difficult conditions. But we are very precise in the application because the plants are getting signals in a few hours, responding in 48, 72 hours, and then the signals is dropping again. So if my treatment is happening too early, the signal of responding to the stress can be lost. You see, if I'm treated too late, the signal is too weak to make the plants adapted to the critical conditions. What we can do is also which is what we call priming. What can be done is also to apply after, for the recovery of the plants. But the products are completely different. So what I apply before has to be done in a specific moment. What I apply after is a different product in different moment. And the last large category of products which are working on the subcomfort of the plants can be applied during the whole cycle, but according to the phenological stage of the plant, they have to be different in terms of quality and dose rates. So manage biostimulants is a very professional activity. It needs behind a deep science. It needs, when the products are in our hands, to be very precise, accurate in understanding what's happening, how are the plants responding. So biostimulants are not easy product, meaning that we have to become more professional, and the simple messages are really a might. So simple messages on biostimulants are not accepted because they are not simple at all. So thank you very much for your attention.